Good morning, students. So in our today's module, we'll be discussing about new chapter, that is work and energy. The name of the chapter is work and energy. So students, so far we have described the motion of an object when the force acting on it is constant, and this has been done by applying Newton's second law of motion. Now students, but in most of the physical phenomena, the force acting on objects are not constant. Such force include gravitational force or the force exerted by an object to a spring. So to deal with such situation, we shall develop several journal methods by introducing the concept of work. Right, students? So first of all, we should know that what exactly the meaning of work is, right? So now we'll be discussing the intuitive meaning of work, which is quite different from the scientific definition. Like in everyday activity, the term work is used equally for mental work and for physical work. Now here you can see there are some examples which will make you clear about the intuitive meaning of work. For example, you may read a book or exert yourself mentally in thinking about a simple or a difficult situation. Like sometimes what happens, children, that you do a lot of thinking, whether it is simple, whether it is difficult, and you say that I am doing work, right? Similarly, the second example can be you might be holding a weight without moving. So suppose if you are not moving, you are actually standing at one place. Let me just tell you, you're standing here, you're holding a bag, but you're not moving. So at that time also we say that we are doing work, right? This is not the scientific definition, remember students. And the third one you all can see here, you may be carrying a load and moving horizontally with uniform velocity on a frictionless road. So at that time also we say that we are doing work. Let me just increase the thickness for you. Alright, so you all can see here. And the last one is you may be trying hard to move a huge rock which does not move despite your best efforts, though you may get completely exhausted in this process, right children? For example, this is a very big rock. Let me just tell you here. See, this one is rock, very big rock, and you're actually trying very hard to move this huge rock. This is a huge rock, but you are trying very hard, but despite of your best efforts, it is not moving. Fine. So still we said that we are doing work. Now students, in all these cases that we have discussed, according to these are actually according to the intuitive meaning, right? So we should know that what exactly the scientific meaning now. Fine. So let's just quickly discuss the scientific conception of work. So in physics, the term work is used in a special technical sense and has a much more precise definition. So you all can see here. Remember children, this one is the scientific conception. This one is the scientific conception. Remember this thing, okay? Alright, so you can just see the first one. When a box is pushed on a floor by applying a force and it moves through some distance, so work is said to be done. Remember this thing, in this case the applied force displaces the object. Now let this be object here. Let me just draw an object for you. This is an object, fine. Now students, when this box is pushed on a floor, fine, and how will be pushing it? By applying a force. So let me just apply a force here. I have applied the force, fine, and this box moved through some distance. Let that distance be S, and the box, after moving, it comes to this very position, fine. So work is said to be done because the object has displaced from one position to the other position, right children? Similarly, just have a look on the second point. When we pull a trolley by applying a force and it moves through some distance, fine, at that time also we say that work is done. When we lift a box through a height, we have to apply force. In this case, the applied force does work in lifting the box, fine. From all the examples given above, it follows that work is done only in two conditions. Remember this thing, this becomes a very, very important point. Fine. A force is applied on the object. So if we will apply a force on the object, and plus remember this thing, the object should be displaced from its original position. It should be displaced from its original position. So under these two conditions only we can say that work is done. Otherwise the work is not said to be done. I hope this thing is clear to each one of you, right children? So we have just discussed now that we have discussed about the work, fine, work done by a constant force. Suppose let this be the object. We are applying a force in this direction and it is getting displaced. Let this box again be here after displacing. Fine, this becomes its initial position and this becomes its final position, right students? Now see here. So let us assume if a constant force acts on an object at point A, fine, let this point be A and this point be B. So due to which the object gets displaced through a distance S, this is the distance S, in the direction of the force and reach at point B, fine. Then the work done by force on that object will be equal to, work done is equals to force into displacement. Remember this formula. Alright students, so we can easily calculate its SI unit. Fine, how? We know that the unit of force is Newton. Fine, so let's just do it quickly. 1 Newton. And what about displacement? It's 1 meter. So the SI unit of this work done becomes, yes children, very good, Newton meter. Fine, this is the SI unit of the work, or we also call it as joule. So I hope the small concept is clear to each one of you. Thank you students. And remember this thing, that work is a scalar quantity. Fine, work is a scalar quantity. It has only magnitude and no direction. Alright children. Thank you everyone.